Okay, so in this video, we are going to introduce a brand new type of function that you have never studied before, at least not if you have been following the Midland Public Schools Point 2 path. This is something that is one of my favorite things to teach in this class because it's one of the very few things that we do that's just legitimately new for students. We're going to introduce something that's called the logarithm in this video. And we're going to spend several videos, several weeks of class time developing what a logarithm is and how we'll use it. But it connects very closely with the unit that we just finished. So we just finished talking about exponential functions, and it turns out that a logarithm connects very, very closely with exponential functions. So I'm going to explain in this video what that connection is, how those two things go together, and then we'll use that as the foundation for everything else that we do over the next couple of weeks. All right, so here are the learning objectives for this particular video. Right now, you might not understand exactly what these mean because of the fact you don't know what a logarithm is yet, okay? But in this, the first two are pretty self-explanatory. We're going to define what a logarithm is. And remember, in our class, for the most part, when we talk about definitions, we just mean have a working understanding. Just be familiar with them, okay? So I don't need you to have an exact word-for-word memorization of anything. In fact, I'm not even going to give you that sort of a definition, okay? Second thing is be familiar with the notation. So when we see a problem that has a logarithm in it, you should be able to read that problem and understand what it means, okay? I will say as a side note, there are two sort of shortcuts as far as the notation of logarithms go. I will not be showing you those shortcuts in this video. I will show you them in a later video just so you're aware of that, okay? Then last but not least, and this is the one that probably you won't understand just yet, but we want to be able to switch back and forth between exponentials and logarithms, okay? And that's the final learning objective for this video. So let me start getting into just big picture, how all of these things fit in the concept of a logarithm as it's defined in math, okay? So here's something that we know already, okay, that we've seen before. So this is something we've seen from back in the day, okay? Back in the day, we've done problems like this. X squared equals 4. Can I figure out what X is? And the answer is yes, we know how to do that because we know there's an operator that cancels out squaring. What cancels out squaring is square roots. So if I take the square root of both sides, that enables me to figure out that X has to be either a positive or a negative 2, okay? And we know similarly that if I had something like X cubed equals 27, we have a way to cancel out cubes. I can do a cubed root. And the cubed root will cancel out that cubed and enable me to figure out that X has to be equal to 3. And when we studied this, we talked about like why you would need to add a plus or minus sign here, but you don't need to do it there. And that's all stuff that we've done before. But the bottom line is the reason that this process works is because square roots are the inverse operator for squares, and cubed roots are the inverse operator for cubes. In general, a radical is the inverse operator for a power, okay? A radical is the inverse operator for a power. But here's the thing that we've discovered now. We've discovered that the variable doesn't always have to be in the base, that it's okay to have a variable in the exponent, something like that. This is a problem that now we have seen as we've studied exponential functions. So now I don't have a power expression anymore. Now I have an exponential expression. So it wouldn't make any sense to say, well, I'm going to take the xth root of both sides because what's x? I don't know what x is. And if I don't know what x is, I can't take the xth root of 8. That's not something I can do. So if I want to figure out what x is, I need a new kind of inverse. Okay, so a radical will cancel out a power, but the type of inverse that I need to cancel out an exponential is the logarithm. Okay, so this type of problem, to undo the exponential, I will use a logarithm. Okay, and that's the reason why we have logarithms. Well, not entirely. The history of logarithm is a little more complicated than that, but the bottom line is we're going to use logarithms, or the main purpose in our class for logarithms is going to be, one of the main purposes is to undo exponentiation, to let me solve an equation like this, okay? Now, that brings us then to our definition. So we're actually getting into our learning objectives here. for our class, that's simply how we're going to define a logarithm. Definition of logarithm. In our class, we're just simply going to define a logarithm as being the inverse of an exponential. Okay, a logarithm is the inverse of an exponential. All right, and again, remember, this is different than a power, right? The radical is the inverse of a power. The logarithm is the inverse of an exponential. Okay, so let's introduce the notation that goes with this, and we'll talk about how this works a little bit. Okay, so the notation. Okay, if I have an exponential expression, something like 2 raised to the x equals, for right now, I'm just going to put in a variable, equals y. Okay, and we'll deal with numbers here in just a second. But if I have something like 2 to the x equals y, this is exponential notation. And the reason why we call it exponential notation is, that's a period, is because there's an exponential expression. All right. Now, if I want logarithmic notation, I'm going to have all this same information, but things are going to move around. And how do they move? Well, specifically, we know from previous lessons about inverses that what inverses do is inverses switch the domain and range, right? That's something that we know. They switch the domain, which are the inputs. Usually we represent them as an x, with the range. They switch the domain with the range, and the range is the outputs. Usually we represent those with a y. So in my exponential expression, my inputs are going in here for x. That's where my domain is. And my outputs are coming out as the answer. That's my y. Okay. So in a logarithm, the two things switch. So the thing that was my input, now all of a sudden, that's my answer. That's my answer. And the thing that was the answer, now that's what I'm going to put into my problem. Okay. So this is now, this was the old answer, but now it's the new input. It's what we're putting in. And the same thing with this. This was the old input, but now it's the answer that we're getting. Okay, but I still haven't shown you the actual logarithm. So here's the way that we express a logarithm. We use the abbreviation log, L-O-G, L-O-G. So I'm just going to write log of y equals x, log of y equals x. Okay. Now that's actually not the full thing. There's one other piece, but log of y equals x. Why does there need to be another piece? Well, I need to have another piece because I need to know what was the base over here. Remember, the thing that has the exponent, that's called the base. The thing that has an exponent, that's called the base. And so this somehow needs to reflect the fact that I was working with a base of 2. So the way that we do that is we just copy that number into the problem as a subscript right here. A little tiny 2. That's how we indicate the base. So the way that I would read this expression is I would say log base 2 of y is equal to x. Log base 2 of y is equal to x. So notice the way that I'm switching back and forth. Instead of writing it with a superscript, like an exponential power type of deal, I'm writing with a subscript. Okay, and then I use just the abbreviation log, to represent my logarithm. And then the only other thing is I'm taking my input and my output and I'm switching them. That's it. So some of the types of problems that you'll see in tonight's homework asks you to do this exact process. So let's say I have 3 to the a power is equal to b. Okay, if I wanted to switch that into logarithm notation, well, if you think you've got an idea, pause the video and do that real quick. All right, so whether you tried that or not, let's talk about how this works. So the first thing is if I'm going to switch this into log notation, I need the abbreviation log, L-O-G. I need that. Okay. The second thing is I need to account for my base. So my base was a 3. So next to log, as a little subscript, I write a tiny number 3. And then the other part is that my answer becomes the input, and the old input becomes my answer. And so that would be the way I would take this exponential notation and rewrite it as logarithm notation. So that's what this example does, is rewrite the exponential notation using logarithm notation. Okay, so that's what we've done there. And of course, we can do this with variables. We can also do this with numbers. So example number 2 is going to be the same task, rewrite the exponential notation using logarithm notation, but let's do this one with numbers. So we know that if you take 2 and you raise it to the 3rd power, the answer will be 8. That's something we've done before, right? 2 times 2 equals 4, and then times 2 again would equal 8. So now I'm working with all numbers. If I wanted to switch that into log notation, okay, think about how you would do that and then give it a try. Once you've tried it, resume the video and let's see if your answer matches what I put. All right, so hopefully you've tried this. You should say, first of all, that we're going to take a log. So you should write the word log. You should indicate that we're working with a base of 2 by writing a little subscript 2. And then you should take the thing that was the answer and make that what we're putting into the logarithm, then an equal sign, and the thing that was the exponent, that becomes our answer. Okay, so again, the way you would read this is the log base 2 of 8 is equal to 3. Log base 2 of 8 is equal to 3. Now, the math process for finding an answer like this, in other words, if I were to just simply ask you, hey, what's the log base 2 of 8? For you to figure out the answer is equal to 3, that's something we're going to talk about in the next video. So in this video, you're always going to have a full exponential equation, and you're just going to rewrite that into a full logarithmic equation. You're not going to have to actually evaluate anything in today's homework. All right, so this is the basic idea of the way the notation works. So we've got our definition. The definition is that the logarithm is the inverse of the exponential. And we've got our notation. And again, this is the basic notation. There is actually 2 kind of shorthand notation that goes with logarithms that we'll look at in a later video. But for right now, this is our basic notation. Okay. Now, with all of that said, the third thing that we have to do is not only switch back and forth in notation, but also switch it back and forth with a graph. And so I just happen to have here a graph that we're very familiar with somewhere. There it is. It's the graph of y equals 2 to the x. Okay, we've looked at that in multiple videos and multiple homework assignments, so we should be familiar with that. We should be very comfortable if I asked you to make this graph to do that and to figure out that these are some points that are on the graph, right? We know that the way you find these points is you just plug in a number for x, and then you figure out what does 2 raised to that power equal, and then that's your y coordinate, right? So this is stuff that we have done, and we should be very, very comfortable with these types of problems. So for now, we're just going to start with that. So if you need to pause the video to copy this graph, then do that right now. Pause the video and make a copy of this graph. And once you've got that graph in your notes, what we're going to do over here is we're going to draw a graph of the logarithm function. So we're going to graph y equals the log base 2 of x is what we're going to do. Okay, so make sure you've got those ready to go, and then we'll talk about how to make that graph in just a second. All right, so hopefully you've got these ready. It did occur to me as you were copying this graph, I noticed my asymptote is not very good. I kind of drew it a little bit above the x-axis. You know that that should be right on the x-axis, right? We should be familiar with that. So I apologize for that little bit of sloppiness. Hopefully when you drew it, you made that asymptote right exactly on the x-axis like it should be. So I apologize for that. All right, now, we have done before problems where we talk about how you switch a graph into its inverse. So this is the graph of an exponential over here. This is the graph of an exponential. And what we are going to do is we are going to make the graph of its inverse. And what's the inverse of an exponential? A logarithm. Okay, graph of a logarithm function. So we have the graph of an exponential function. We're going to make the graph of a logarithm function right now, because that's the inverse. And if you remember what we did before when we studied inverses, was we said, hey, inverses literally just switch the domain and the range. So if I know an x value, that x value becomes a y value. And if I know a y value, that y value becomes an x value. And similarly with the asymptote, if this asymptote was a y equals 0, then in the inverse, that's just going to switch into be an x equals 0. And so we can start drawing all our bits and pieces. If you recall when we did this before, I always started with the asymptote. I think it's helpful to have that as an aid when you're making the rest of your graph, to make sure that you actually draw something that's getting close to the asymptote without touching it. So now the graph that, or the asymptote that was y equals 0 has become x equals 0. Okay, so the thing that was my x-axis, now that is my y-axis. As far as my points, all my coordinates just switch. So if this had the point 3, 8 on it, then on the new graph, I'm going to have the point 8, 3, because these just switch. So the y value was 8. Now that's an x value. 1, 2, 3, 4, 5, 6, 7, 8. And the x value was a 3. Now that's a y value. 1, 2, 3. So this point right here is a point that's on my inverse. Okay. Again, this x and y are just going to switch. So the x was a 2, now that's a y. I'm going to go up 2. And the y was a 4, now that's an x. So I'm going to go over 4. And now this point is a point that's on the inverse. And I can do that with all of these. So here I'm going to go over 2 and up 1, because I'm going to switch my x and my y. Here I'm going to go over 1 and up 0, because I'm going to switch my x and my y. Now I'm going over a half and down 1. And now I'm going over a quarter and down 2. And we could keep going, right? The next one would be if I plugged in -3, I would get an 8 for this. So I could go over an 8 and down 3, and I would get a point right about there, and so on and so forth. So now if I connect all these dots, I'm asymptotic to the y-axis, to x equals 0. So I'm cruising along the axis, and then it starts to bend over. And as it bends, it starts to stretch out. And so my next point would be way out at 16, 4. So I'm not going to get up to 4 until I'm way out at 16. So it's going to take a long time to get there. Okay, and so that's the basic shape of a logarithm function. And this is the third type of problem you'll have in your homework tonight. I will give you an exponential graph that has points labeled on it, and then you'll use that graph to make a logarithm graph, right? Again, not until later videos will you need to be able to start doing this type of thing without the exponential graph to help you. That will come later, all right? But for right now, you'll always have the exponential, and you'll use that to help you make the logarithm. So that takes care of it for this video. We have taken care of all of our learning objectives. We handled what the definition of a logarithm is. It's the inverse of an exponential. We handled the notation, how the different bits and pieces switch. And then we talked about how to switch both the notation and the graph, starting with an exponential and turning it into something that's logarithmic. All right, so hopefully this helps you. Thanks for watching. Have a good one.